For part A of question 1, to find the grams of H2SO4 produced, we'll first find the limiting reactant. We will start with our grams of sulfur, convert that to moles, and then use our mole to mole ratio to convert to moles of H2SO4, and then use the molar mass to find grams of H2SO4. And then we will do the same process but for the O2. This shows us that our limiting reactant is H2SO4, and that means that however much the limiting reactant produces is the amount that is produced, so that means that 210.9 grams of H2SO4 are produced. For part B, we're asked to find the excess sulfur, or excess reactant, which is the sulfur. So we start with our 210.9 grams of H2SO4, which is the amount produced. Then we'll use molar mass to find moles of H2SO4, use the mole-to-mole ratio to find the moles of S, and then we'll use the molar mass of sulfur to find the grams of sulfur consumed, which is 66.02, and then we subtract that from the 125.5 grams of sulfur initial, and we will get a 59.5 excess sulfur. For part C, we are finding the grams of sulfur produced if we have 1.27 kilograms of H2SO4 with a 86.3% yield. So we start with those kilograms, and then we'll convert that to grams. Then we use the molar mass to convert from grams to moles of H2SO4, use the mole-to-mole ratio to find moles of sulfur, use the molar mass to find grams of sulfur, and then we'll use that percent but 86.3 over grams over 100 grams to find our final 358 grams of sulfur. To find the molecular formula of this unknown compound, we will start by finding the grams of carbon and hydrogen. We are given the grams of each that is produced, so we start with the 1.511 grams of CO2, convert that to moles CO2 with molar mass, do the mole-to-mole ratio of 1 mole of C to CO2, and then convert that to grams using the molar mass, which gives us our grams of carbon. And then we'll do the same for the hydrogen, but using the molar masses for hydrogen. To find the grams of N, we know the percent by mass of N, so all we have to do is take the mass of the compound and multiply that by 9.27 grams of N over 100 grams of N, because that is 9.27%, and that gives us our grams of N. And then to find the grams of O, we will take our mass of the entire thing and subtract the grams of carbon, and the grams of hydrogen, and the grams of nitrogen, and that's how we will get our grams of O, or oxygen. Next, we'll find the empirical formula by first finding the moles of each element by starting with the grams that we found, and then dividing it by the grams from its molar mass. And as you see, nitrogen has the smallest number of moles, so we'll divide everything by the moles of nitrogen, giving us 8, 9, 1, and 2. Giving us C8H9NO2 as our empirical formula. And then we are given the molar mass of the molecular formula being 147 grams per mole, and we can calculate that the empirical formula's molar mass is 151 grams per mole, which gives us about a 1-to-1 ratio, as the molar mass of the molecular formula is plus or minus 10, and that means that the molecular formula is the same as the empirical formula, meaning it is C8H9NO2.